Okay. And so make sure you have the notes in the homework if you do not already. But we're just going to do 7-1. I could push into 7-2 today, but I did this on Thursday with the kids before they went on spring break, and we didn't really feel like pushing. So we're just going to have a nice, easy day back into math, okay? First part says solve with substitution. So we are going to use substitution where we replace something back into one of the equations. If at all possible, I like to plug in what I've got. So I see x squared is going to go in for my y. So I'm going to replace that y with my x squared. I'm going to say x squared, and I'm going to plug in the rest of the equation, minus 9 equals 0. And then we just solve for x. X squared equals 9. Remember when you square root both sides, it's not just 3, it's going to be plus or minus 3. So x has two possible answers, positive 3 and negative 3. Now, the easy thing about this one is it doesn't matter if you plug positive or negative 3 in, because if we're going to do y is going to be equal to positive or negative 3 squared. And whether I put positive or negative 3 in and I square it, what should I get out? Y is going to equal 9, right? I do want to write these as ordered pairs because when we have two answers later on, when we plug it in, we should get two different answers. So my two answers in ordered pair notation is going to be 3, 9, and then negative 3, 9. That wasn't too crazy, was it? All right, let's look at the next one. Same idea. I'll do this one with you, and then I'll have you kind of try the other two on your own. I don't care what you do in order to solve, but you need to take one of the equations and simplify it to just equal one variable. So I'm probably going to take the first one. Let's add y to both sides. So I get x equals 3 plus y. And then we're going to substitute that in for my x over here. Now on this one, I've got a lot of y's going on. I actually am going to move everything to one side so I will have a quadratic. And I like my y squared or my x squared or whatever squared to be positive. So I'm going to add that y squared to both sides. I'm going to minus my y from both sides. I can combine that with the 3y. So that's why I put it directly underneath. And then I'm going to minus 3 from both sides as well. So I get y squared minus y minus 3. Now, this is when we go all the way back to algebra 1 and we get to factor. So I'm like, okay, y squared minus y minus 3. Numbers that multiply to be 3 are 1 and 2. And I want that 2 to be negative, to add to be negative y. So that's 1y and then minus 2y. And that's equal to negative y, which is what we want. I don't know if anybody else's brain stopped working after breaks. I just wanted to go through that basic factoring a little bit slow. All right, now set each of your factors equal to 0. So y plus 1 equals 0. So y equals negative 1. And then y minus 2 equals 0. So y equals positive 2. And then we kind of looked at this last time, but it didn't make any difference on whether I plug each number in. We're going to plug negative 1 in to figure out what x is, and we're going to plug 2 in to figure out what x is. So the first one will be x equals 3 plus negative 1. And that's going to be x equals 2. And so again, I do like to write these in ordered pair notation. So when I plugged in that negative 1, I got out a 2. So we're going to say 2 comma negative 1. And the 2 goes first because it's the x. The negative 1 goes second because it's the y. And then we're going to do the exact same thing with 2. So we're going to do 3 plus 2 and see what we get there. And that's going to be x equals 5. So my other point is going to be 5 comma 2. So it sounds silly, but remember, x goes first, y goes second. Okay. All right, the next two are substitution again. Do you think you can try them on your own? Okay, I'm gonna be quiet for a minute. I'll do my work momentarily on C and D, but I want you to try it for a second on your own without me. There's A and B if you still need to look at those.
Is that plus 0y?
Plus 6y.
6.
Mm-hmm. All right, I'm gonna start my work on letter C if you want to check yourself. Oh shoot, did any of you get to where I got to? All right, this is a special case, right? So we don't have an x equals or a y equals. Now, do you remember, is this no solution or is this infinitely many solutions? All right. This one is no solution. So I remember it by saying this is not a true statement. -12 will never equal 4. So this is a no solution. There's no number that I could plug in for x and or y to get the right answer out. So this is a no solution. All right, once you've done that, go ahead and jump to letter D, try that one. I did get some answers here, so double check and make sure that you got X's like I did. And then I'm going to go plug them in. It's just running in the hallway. What else? All right, once you get your X's, plug them in, get your Y's, and that's my answer in ordered pair form. All right, anybody questions so far? So we just did a whole bunch of substitution. So you see the word substitution, we know what that means, right? Yes, no, maybe. Do I need to zoom back in on D? All right, now we're going to do elimination, which is where we have to keep the two equations separate, and we're going to get rid of one of the variables by multiplying by a coefficient. So just a reminder, again, I'll pretend like we've never done this before. I'm going to multiply, I'm going to do the y. So I see I've got positive 1y, I've got negative 2y. So I'm going to multiply the top equation by 2. Remember to distribute that to all three things. What often happens is we forget to give it to the term on the other side of the equal sign. Don't do that. So that gives me 4x plus 2y equals 20. And then I'm going to combine those two equations. And one of the variables needs to cancel out. So x plus 4x is going to be 5x. The 2y minus 2y cancels. And then negative 520 is 15. This is super easy. Divide by 5. X equals 3. All right. Once you have x, go plug it into one of the equations. I'm going to plug mine into the second one because that x is by itself. So it's going to be 3 and then minus 2y equals negative 5 minus 3. Negative 2y equals negative 8. Divide by negative 2, y equals 4. An ordered pair would be 3, 4. I'll do one more with you, and then I'll have you try 1 or 2 on your own. Does that sound good? Okay. This one, you've got a bunch of different options. I'm probably going to do the y's again because I already have a negative and I already have a positive. So I'm going to multiply the first one by 4. And I'm going to multiply the second equation by 5. Now you could get rid of the x's, just make sure that one's positive and one's negative. I don't really care which one. So that becomes 15x plus 20y equals 30. And then the top equation becomes 16x minus 20y equals negative 92. Make sure all your signs are good. My y's are going to cancel. If something doesn't cancel, you did something wrong. I get 31x equals negative 62. Oh, that's nice. X equals negative 2. And then again, I don't care which equation you go plug it back into, but pick one and plug it back in. I'm probably going to do the second equation, so I'll plug negative 2 in for my x. 3 times negative 2 plus 4y equals 6. Negative 6 plus 4y equals 6. Add 6 to both sides. 4y equals 12, and y equals 3. So my ordered pair here is negative 2, 3. This is really simple math, so make sure you're just not making any silly little math mistakes, okay? All right, everybody good with the front side? Flip it over. I think I have one more that I want you to try on your own, and then we're going to do number 3 together, and then we're done. I told you, it's going to be quick. Promise you, I'm not lying today. So try number 3. Uh-oh, what happened here? We had another special case, don't we? This time, though, I got it all the way down to 0 equals 0. What is that? Is that no solution or infinitely many? Or all reals?
Infinitely many.
Yes. Or I know sometimes they call it all real. So you could write all real numbers, the fancy R. You can say infinitely many solutions, IMS. You can write out infinitely many. You can write out all reals, whatever makes you happy. But since this is true, 0 does equal 0. That's a true statement. That means any number that we pair will work. Okay. The last one we're going to do is just another one of these problems, except it looks a little bit funny. We are going to get to word problems that will kind of end up with this equation. So I wanted to do an example where it wasn't a word problem, it was just the two equations already set up. But we will see this in word problem form later on. So I kind of make note, we will see this again. In this problem, I am going to do substitution. I'm not going to do elimination because there's a plus sign here and there's no plus sign there. So I'm going to take the first equation or the second equation and solve for one of my variables, and I'll substitute it into the other one. Okay, so I'm going to get this one. I'm going to solve for y just because I'm used to having y by itself. So y equals 300 over x. And then we're going to take that and plug that in for this y over here. So 2x plus 2 equals 100. And that parentheses is going to be 300 over x. Okay. Now, we could stop here and put this in the calculator, but we're going to finish the hard part algebraically by hand first, and then at the very end, we'll come back and prove that we could have stopped here and put it in the calculator. So what I want to do is get rid of that fraction, and I'm going to do that by multiplying everything by x. So by multiply everything by x, that will get rid of that x in that denominator, okay? So I'm going to do 2x times x is going to be 2x squared. 2 times 300 over x is going to be 2 times 300, which is 600. And then x times 100 is going to be 100x. It looks messy, but let's move everything to one side. So minus your 100x from both sides. 2x squared minus 100x plus 600. Now, this is where we would factor or where we would quadratic formula. Let's divide everything by 2. Let's cancel 2 out of all of those things. So if we divide 2 by one side, we divide it by the other side. So then this 2 goes away, this becomes 50, and then this becomes 300. So now I've got x squared minus 50x plus 300 equals 0. At that step, you're allowed to look to factor, but I'm going to be honest, I don't really want to factor those numbers that big. I don't even want to see if it works. I'm going to go directly to quadratic formula. So I'm going to use 1 is going to be A, 50, negative 50 is going to be B, and then 300 is going to be C. So we'll do x equals negative B, so positive 50 plus or minus B squared, so negative 50 squared minus 4 times 1 times 300 all over 2 times 1. So negative B, so positive 50 plus or minus negative 50 squared minus 4 times 1 times 300 all over 2 times 1. All right, and then now we just start simplifying. 50 plus or minus 50 squared, which is going to be 2,500 minus 4 times 300, 1,200 all over 2. All right, we'll put in our calculator in a second, but I want to simplify this first. We've been doing a lot of radicals with geometry, so like I'm ready to simplify it. Does anyone have any questions yet so far? All right, I know that 1,300 can break down to 100 times 13, and I know 100 is a perfect square of 10, and 13 doesn't break down. So this is going to be 10 root 13. And we can't forget the 50, the plus or minus, and then the 2 in the denominator. I know it feels like we've been on this problem forever already, but now we can simplify by doing, okay, 50 and 10 and 2 all have a factor of 2. So that becomes 25 and 5 and then 1. And so our best, most simple answer is going to be 25 plus or minus 5 root 13. throw that in the calculator really quick because we're about to graph this and our answer is not going to be in radical form. It's going to be in decimal form. So let's see about what this equals. Calculator up. So 25 plus 10 or 5 root 13 is going to be 43.03. And then 25 minus 5 root 13 is going to be about 7. I'll round that all the way up to 7. All right, the last thing we're going to do with this problem, if we were just asked to solve it, we would be done right now, or we'd be done with our x's. Before we go, let's go plug it into our y's. So let's go make sure our y is going to be 300 divided by 43.03, and then y equals 300 divided by 7. Okay. So the first one gives us about 7, and then 300 divided by 7 is about 43. So they're about the same answer. So if we were to do ordered pair, it would be 43, 7 and 7, 43. The only reason I would do this by hand is if I was asked to do this by hand, if this was on a no calculator section. However, this could be on a calculator section. So let's go back. All of that algebra we did, we can ignore, and we could literally just go plug this into my calculator. So we're going to go do that. If I go to my y equals, I'm going to plug that 2x plus 2 times 300 divided by x in for my y1. And then I'm going to plug 100 in for my y2. The only thing that gets funny is your windows, okay? So I've got 2x plus 2 times 300 divided by x is my first one, and then 100 is my y2. Could we have any negatives here? Should we have any negative x's, negative y's? Nope. So if I go to my window, my x min and my y min will both be 0. My x min, my x max, I don't really know what that is, so I'm just going to guess. I'm going to put in 50 and see what happens. But my y max, I know it has to be over 100 because I know that 100 is like one of our marks. So I went up to 150. I hope this is enough to see my picture. Does anyone have a question about my range, domain or range? Okay. Graph. Oh, nice. I got 2 little marks right there. So I'm going to go figure out what those intersection points are by doing second trace intersect. I'll go left bound. I'll go right bound. And my first one is at about 7. Ooh, that was one of the answers we had gotten before, right? That's cool. And then I'm going to go second trace intersect at my other point. So I'm going to go left bound over there and right bound over here. And that's about at 43. So that's where my second point came from. So all I wanted to prove there is that there's just 2 different ways to do this. So I just wanted to walk you through those 2 ways. Okay. That's all I really want to do today. You have the rest of class to work on your homework. And I do want that 7-1 homework due next time I see you. I'll end this.